Welcome to homework.
Okay, so we've got optically pure 2-bromobutane. And what we're doing is reacting it with heat and water. And we get S-butanol and R2-butanol. We get a mixture. Oops. And we get twice as much of the S as we get of the R. So the first question is, what's the enantiomeric excess? Okay. Well, what can we do with this 2-to-1 ratio, right? To get an enantiomeric excess, we need to know the percent of the higher concentration in the enantiomer, and we need to subtract the percentage of the lower percentage concentration. Okay, but we don't know percents, we just know ratios. So is there a percent that corresponds to a 2-to-1 ratio? Yeah, there is. It's 66% and 33%. How do I know this? Well, if you're ever in this situation, all you need to do is take either of the ratio numbers and divide it by the sum, right? So 2 divided by 2 plus 1 times 100 gives you 66.666 ... And if we want to do the other side, we do 1 divided by 2 plus 1 times 100, and that will tell you the percentage of that enantiomer, which is going to be 33.333 ... Okay. So if we want to finish this formula and get the percentage, it's going to be, well, I kind of truncated here. I didn't put the dots in the, so let's call it 66.66% minus 33.33%. And our final answer, 66 minus 33, is 33.33%. So our enantiomeric excess, when we have these enantiomers in a 2-to-1 ratio, is 33.33. Great. Okay, now we need the specific rotation. Okay, so recall that our enantiomeric excess was 33.33%. So all we've got to do basically is find the specific rotation for the pure and S enantiomer and multiply it by 33.33 over 100. Okay, so I'm assuming this is in your book, or we could just Google it. We need to know the specific rotation of the pure S enantiomer. So S, I Google S2 butanol rotation. Looks like the specific rotation of S2 butanol is 13.52 degrees. So if we multiply this by 33.33 over 100, we get 13.52, 4.17. Right. So remember, this is for the pure S. We don't have pure S. We have an enantiomeric excess of 33%. So we need to multiply the pure rotation by 1/3, or 33%, to get 4.17%. Right. So we calculated the enantiomeric excess, then whatever that enantiomeric excess is the percentage by which we multiply the pure rotation of whichever enantiomer we have in excess to find the specific rotation of our solution. That's exactly what we did. We said, okay, 2-to-1 ratio, that means our EE is 33.33. We have an excess of S, so we need to find the rotation of pure S, and we need to multiply that by 33.33 over 100 to find out what our solution's rotation is. And we did exactly that. We took 33.33 over 100, multiplied it by 13.52, which is the specific rotation of the pure enantiomer, and got our answer 4.173.